Hi everyone. In this given problem statement of climbing stairs, you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Let us take this example of n equal to 3. And here, right, initially I would be at zero's position. From 0, I can climb one step to reach step number 1, or I can go to 2 steps. From 1, I can go another 1 to 2, and here I can go to 3. So this would be one value. From 2, I can reach 3 by going one step, or I can reach 4. If I go to 4, it is going to be out of bounds and I am not going to further calculate it. From 2 again, I can climb to one step, and this is going to be my another result, and here it is going to go 4, so we are not going to calculate it. So here, right, the total number of ways to climb is there are 3, so the answer would be 3. And to solve it, right, we used DFS, or let's say recursive. So here, right, what are the two base cases that we're going to have? Our base case is if n equal to 1, we are going to return 1. If n equal to 2, return 2. Else, what we are going to say? Return n minus 1 plus n minus 2, and let's see the function value. Now let us take a bigger example, right? And it might look for you very simple, but here if you understand, right, it would be 2 to the power n, which is not a very optimal solution. Let us take a bigger example, right, where n equal to 5. So for 5, right, it is going to get started, let's say at 0. We can go 1 and 2. Then from 1, it can go to 2 and 3. Then 2, it can go to 3, 4. From 3, it can go to 4 and 5. At 5, we're going to get our first answer. At 4, right, we are going to get our value. So it would be another 5, and it is going to go out of bounds, so you're not going to calculate it. Here, right, we got our first result in a way, but the problem is, and I'm telling you what would be the issue, right? So with 4, right, here I can go to 5, and I can go to 6. 6, if I get it, I'm not going to calculate further. But the thing is, right, you're able to see, right, there are a lot more calculations happening. And if I do 2 to the power n, right, it would be like 5, so it would be 1632, I guess. So 32 is a big number, right? And if let's say if there are 10, right, it would be exponentially increasing, right? So how do I calculate it, right? If you look out here, right, here we have already calculated what the value of 4 is going to be, how many instances the 4 is going to contain. So if it's 4, right, we know the result is going to be 1. So here, right, if I get 4 again, do I need to again calculate the result? It's not, right. I can store it in some form of a memory so that I do not have to recalculate it. Means if I get a new value, then let's say I can come and 3, right, we got 3 for the first time. If we calculate it, right, how many 5s were there? 2. So we got the result, right, 2. And here, right, uh we can keep on calculating. We got another 4 out here. So what would be the value of 4? We know it would be 1. Then value of 2, it would be 3. In this way, we can keep on calculating. And if we get 3 here, right, we know it was 2. So again, it would be 5 out here. Then this way, it is going to calculate, right? Because we are going to save it in a kind of a memory store. And that is what is dynamic programming. So basically, right, if I had to say what is dynamic programming for you, right? So dynamic programming is if we are computing the same value, right? Instead of keeping on computing the same thing that we have already computed, we can store it in a form of in form of some memory. Let's say it could be a map or could be a hash map, could be a dictionary, right? And let's say when it is going to get calculated again, instead of recalculating it, we are going to take the previous calculated result and just add it. So that is the basic fundamentals of dynamic programming. This is one of the most simple dynamic programming concepts. Now let us jump to the Python solution where we are going to understand or how can we create a program to calculate it up. So the first thing that we need to do, right, we need to create our base cases. So our base case is if n becomes 1, then we can return 1. If n is 2, then return 2. Else I can say return, and I can call the function. So self dot mb stairs, and here I can say there are two ways of taking it, right? In -1 and in -2. So again, self dot stairs in -2. Now if I run this function, right, one spelling error, and here I have not added dynamic programming as of now, right? So if I try to run this code, as you could see, the test case is passed. But what is the problem, right? If I submit it up without adding a memoization, then how it is going to calculate? It is taking time to run. Let us see if it's able to run it, or later will it give a timeout error. So as you could see, right, it says that time limit exceeded, because for n to the power 42, right, the time complexity would become massive and it won't be, you won't be able to comprehend or calculate it. So how to do it, right? We can introduce memoization. So how it is going to work? So here, right, I can simply say memo and it would be an empty dictionary. The first thing we're going to say, right, if n in memo, then I can say let's not recalculate it again, just simply return the value. So return memo of n, and here, right, I can say memo of n equal to this value, and we have to pass the memo also. So memo, and similarly you have to pass it again out here. And at last I can say return memo of n. Let me run the code now. I hope I'm not making any errors. So it ran successfully public test cases. Let me now submit the code. And as you could see, right, it ran successfully. It is beating 100% of the submission, and the time complexity of it is, right, is going to be big O of n, and the space complexity will also be big O of n. So that is pretty efficient in all standard by just introducing a memoization in dynamic programming. That's all for this video. See you in the next one.